Yeah, hello and welcome to my presentation about potentials for closed-loop applications with track and trace. Thank you also for the invitation to have the opportunity here at the Techtank Conference having this presentation to you. The next few minutes I want to share some ideas about our track and trace solution and how we try to use this solution to go further and achieve closed quality control loops. Just a brief agenda for this presentation. We will start a little bit about the design principles of these solutions, having a little bit of the ideas of what kind of measurement technology is integrated, what about the marking and the detection technology which is used, the data modeling and the architecture of the solution, as well as I want to show you how the track and trace application works in its basic functions. So, and of course, I will give you afterwards a little bit about the benefits we evaluated, how the solution works, and what are the USB from such a solution. And of course, if you have pending questions afterwards, I'm happy to answer it after the presentation to you. Just a brief overview about what kind of solutions we have available in the press shop. Today in the automotive industry, we are very often talking about the OEE of a press shop. And of course, we want to improve this kind of KPIs. And we are working on solutions to give you the right tools to improve your performance, your availability, and also your quality. Regarding performance and availability, we have a rather new solution on the market, the shop floor operations management, which is helping you to improve on this side of the OEE. And on the same architecture, on the same hardware and software stack, we have also our track and trace solution, which is focusing on the quality of our produced parts. And what's about this track and trace solution I want to show you in the next few minutes. So when we're talking about the track and trace regarding in the press shop, we have a really strong focus on the parts quality. And when we are talking about part quality, we are talking especially about the geometry of the part, the surface quality, and also of mechanical properties of those parts. Especially the mechanical properties are relevant for structural parts or safety parts, as you can understand. So when we are talking about quality, we have to have in mind that this quality can be influenced from different influences. Starting, for example, with the environmental influences. So this can be the storage condition or handling conditions, how you treat the material during the storage. Then we have, of course, the physical properties of the material, which are really strongly influence what is happening in the forming process, for example. This can be the material properties like the tensile strength, the yield strength, roughness, lubrication, or the age of aluminium, for example. When we are talking also about influencing parameters, we have to have in mind the production parameters, of course. What we have also to record when we talk about track and trace, we need the possibility to record and track all the process parameters like, for example, the re-oiling or the drawing cushion forces, the press forces, the press speeds, forming speeds, temperatures, and so on, which have also influence to the quality of the formed part at the end. And last but not least, what we also have to cover, we have to have a view on our organizational factors. We know that there is different performance of shift teams, for example. There is also a different way how to treat problems if they are coming up. So we have one shift teams working or trying to solve problems in one way, and we have other teams doing it in another way. So what we also found out is that we can use track and trace as a technology also for knowledge transfer between those shift teams. So how can you perform really well and how can you solve problems? And for this knowledge transfer, it's also important to have a focus on this aspect as well. So there are mainly two questions we want to answer very quickly when we're talking about track and trace. So one is, how quick are we able to recognize an error? And this is really essential, talking about the press shop, that we recognize this error very quickly when it occurs. And the second question is also very interesting and important. So when we have an upcoming failure or an error, we want to know where is the cause of this failure. And of course, by analyzing all this data and information, it's also a question about how can we make our processes more stable in future, and are we able, for example, to avoid errors in advance. So this is our motivation behind the track and trace solution, and is also the way how we developed it for the press shop. So just to give you an overview about how we set up the solution, I want to show you some design principles about the solution. So regarding the system, we really tried to do it very comprehensive, from the coil to the finished part, to start with the coil data and look at every process step during the blanking and also the stamping afterwards, and track the part until it's finished in the part rack at the end. So what we also tried to do is a resource or optimized integration. What does that mean? So we have a lot of processing currently on our PLCs, and we also do the integration in that way that we add a lot of functionality into these PLCs and do a resource optimized integration in our production lines. The function and the solutions are scalable and flexible, basically. So it does not matter if you start with a single production line and scale up to several production lines, or you start with several lines. So basically it's very flexible and also scalable to your needs. The solution and the product has a really comprehensive connectivity. Everything is connectable with open APIs. And this is very important when we are talking about data science, for example. So in our way, it was very essential that the data can be accessed very easily, and that we are able to do analysis, maybe also with different tools which are available on the market, like Python, for example, or MATLAB. So the solution has a very open REST API documentation, and it's very easy to access this data and doing further analysis in external tools, for example, which is also important to follow new ideas and do new developments about this data. What was also very important from us from the very beginning was that it's a bidirectional data flow solution. What does that mean? You know, we have a lot of black box data recording done in the last few decades. So, but it's very difficult sometimes to bring data to the back to the production line. And this is essential when we are talking about closed loop applications. We have to feed information and data back to the production line, and giving also the possibility to react with this data to the current situation. So our solution was built up in the architecture also as a bidirectional data flow solution. Just a few ideas about the data modeling. When we are talking about the data modeling, typically we start with the coil, basically in a press shop. When you scan the coil, typically there is some background information coming from your coil supplier with the test certificate. With this test certificate, you get information about the supplier, the material, the chemical composition, the mechanical properties of the material, the pre-lubrication. You also get some kind of tolerances and specifications with in this material should be. And what we can do afterwards also is to do an additional measurement again in the coil line. That means on the basis of a length we can do integrate measurement technology. And what we basically do is also we cut this model into pieces, because this is what you do in reality. You cut out of blanks out of this coil and map this data to the single blank. Afterwards, you're processing these blanks to form parts. That means it's somehow getting through the blanking process, going onto a pallet, and this pallet is moving to a tandem press line, and you're processing this part to a finished part in this within this press line with several strokes. So what we are doing is this full tracking. That means in the press line we take again this blank, add some data from the press line, and at the end what we get is a full forward and backbatch transparency. That means we know very precisely which parts come out of which coil, and we can also trace back. So if I have a specific part with a single part ID, I can trace back which was the coil where it was processed out of. So this is the data modeling, and this is also how we try to give a full transparency about the production process. So starting in detail about the solution. When we're talking about track and trace, we start typically with the blanking line. Here we have also the target and the challenge. We start with the continuous process out of the coil. So we have data per coil meter in this section. And then on a certain point, we cut this blank or this coil into pieces. Then we get discrete parts, and then we have to do a data mapping from the coil data, from the current meter to the finished blank, which is put on the pallet typically. So starting with the scanning process, we start to do the identification of the coil typically. As I mentioned before, we get all the coil data, and then we can integrate further measurements to do additional measurement on the coil. That means we could measure the thickness, for example, roughness, the lubrication, or material properties. These sensors are already available on the market, and we can do a really good integration into the coil line. So that depends also on the space requirements and the conditions, how the sensors are integrated typically. But here you see an example how we did it in our joint venture in Smart Press Shop in Halle an der Saale. We have integrated a thickness measurement with 3 sensor heads on each side, on the outer side and on the center position. We have a measurement of the oil thickness. It's 1 sensor head on each side, on the upper and the lower side, which is moving on the transferal direction. And we have also in the same principle the measurement of the roughness of the coil. So the detailed coil quality is recorded on a length base, of course, and this is how we do the measurements. We are mapping the measurement data with the coil length typically. And we can cover their different conditions and situations. So we have a multiple setup function of 1 coil ID, for example. So it's the possibility that you process 1 coil in separate orders, working orders. That means you do a multiple setup of the coil. We can cover this, of course. We can add some really important functionality like the information of the state of the coil. That means which part of the coil was trimmed away at the beginning, for example, which is the good section of the coil, or are there sections which are scrapped afterwards, that you get also a balance of how you use your coil material in total. At the end, after the the measurement, we do a precise mapping of the coil information to the single blanks. So at the end, in the data model, the blank has all the information out of the current meter and have it precisely mapped to the discrete part. So we have also the possibility to integrate a marking station. If we're doing a full equipped track and trace solution, we have to mark all the blanks with unique IDs. Here you see the example of a laser marking station. So this can be integrated in line. That means we do the marking in the processing, as the example here shows, right in the laser cell, for example, or we can integrate up to 4 laser heads from the upper side, but also from the bottom side. We have a really short distance to the cutting process, and this is very essential to have a really precise alignment between the outer contour of your blank and the position of the marking. So here you see a detailed view on what kind of parts can be marked. Typically, we can do it in conventional blanking lines as well as in our laser blanking lines. And there are different positions where we can integrate such marking. What you can see here is also that we do a clear type marking. That means an alphanumerical code here. This was the challenge in this project, that we need a really small marking and also the possibility to do a marking of the shell parts. The specification here is that the marking must not be visible after the painting. So in this case, we reached that goal with a slight alphanumerical code, which has also only the depth of a few microns, but we are able to read this code very safe in the press line and in the other stations afterwards. So it's no problem to do the identification of the blank afterwards. So every process data, typically which is connected to or related to a blank, is recorded and is also saved in the blank model. And this means that we have precise information about, in this case, about the laser power, the process gas pressures, and so on. So looking at the stacker at the end of line of the blanking line, we are also able to do a precise tracking of the blank with the precise ID on which pallet or on which nest is the blank put. And we get the number of blanks and also some certain stack parameters which are available in our data models. So now switching to the press line, we are focusing also that we do a continuous part tracking, not only on the front of line or the first press stage, we do it really through until the end of line area. So we start typically with the identification of the part ID. That means we have a camera station, we read the codes and have an error correction at this stage. We have also a full model doing the full inline tracking. That means if you have a single part or multiple part processing, we can cover all the situations by having the right bill of materials and working plans and doing the integration for each single part in the data model. We record typically all the process parameters from all the press stages which are relevant for the production. That means we have information about the re-oiling values, we have information about the cushion values, the forming speeds, and so on. We can save this information to the part ID and having again the full traceability afterwards. So even if we have additional sensors integrated in the production line, like vision systems or additional dye sensors, we can cover also this and put this information to the specific and unique ID, that we can match all the data together, having the part ID as a unique identifier in the data model. As you can see here, here's an example of the track and trace inline tracking of the draw-in measurement. It's a technology, camera-based technology product, which we can integrate into the press stage 1. That means right after forming in press stage 1, we do a measurement of the flange and having the discrete draw-in positions available. Here we can check for deviations, and what we plan to do with this solution in detail is that we do a closed loop application out of this data. But as you know, it's very complex in the forming technology. It's not only essential that we look at a draw-in measurement and doing a simplified control loop. So we have to integrate a lot of information and data in addition. This can be inline information like further parameters from the line control system. And this can be also other material parameters coming from a coil line or from a coil information. So by having all this information available, we can adjust the cushion forces by calculating with different models. And at the current situation, we're really strongly modeling on this case of models to adjust, to have automatic adjustment on the cushion forces, having all this data and information into the model. So we also able to do a final quality or integrate a final quality inspection. This could be a manual inspection, but this could be also an automated vision inspection solution. And as you all know, we have different destacking solutions available. Whether you have a manual destacking or automatic racking system, we can add the information where a part is going into which rack. So, and this makes the complete picture out of the full production in a press shop, starting with the coil until the finished part. So in the next slide, I want to show you a short video about our smart press shop solution. It was recorded in the smart press shop, and here you see some impressions about our solution. The press shop is equipped with a laser blanking line, a tryout press and a press line, and it's a fully digitalized factory, nearly paperless, and we also had the opportunity as Schuler to integrate and develop new solution in this environment. So all the parts manufactured there are typically marked and followed with the track and trace solution. So every process step is recorded and is stored in a track and trace system there. Yeah, let's come up to the summary. What are the technical benefits of the track and trace solution? Of course, we have a full transparency about material, process, and the quality. And with this data, we can really do a good analysis for closed quality control loops. And this is what we are developing at the moment, dealing with the data to develop automatic control loops, reacting also in the right way with deviations in the process. We have a really comprehensive connectivity and automated processes with also for the supplier, the ERP, ME systems, the track and trace, and the production line. And of course, we're able to use this data with big data analysis and also artificial intelligence. What are the economic benefits out of this solution? Of course, we produce less scrap with these solutions because we find the failures and the errors very quickly and earlier, have a higher availability of our production lines, and also reduced rework. So thank you very much for your attention. And if you have any questions about our solutions, you're very welcome to ask the questions. I will try to do my best to answer you also the question. Thank you for your attention.